On this episode of Global Topic, I'll have a conversation with Joe Davis, Vice President of Sales Engineering at Tesla NanoCoatings. Joe and I will have a conversation on the topic of carbon nanotechnology and nanocoatings for corrosion protection. Welcome to Global Topic, the go-to series for the global corrosion and protective coatings industries, exclusively here on YouTube. In this series, you'll find technical content, information, and the latest industry news and events. And now for our interview. Hey, Joe, welcome to Global Topic.
Hey, Jim, thank you very much for having me. Excited about the episode.
If you could do me a favor for the viewers, if you could go through your professional background, and also if you could talk a little bit about Tesla NanoCoatings, what you do, and everything like that.
Sure. Thank you very much. My background is, as far as the paint industry goes, I've probably been involved now since the mid-1980s. Been in a lot of different aspects, a lot of different positions. So been an industrial painter. I worked for coating manufacturers, coating inspector, as well as a consultant for a lot of multinational companies. So a wide variety of different things that I've done. Got interested probably in the nanoscience, probably early 2000s. And that ultimately led me to joining Tesla NanoCoatings, which is where I work now. And I handle their product and their application engineering department. And kind of joined them basically because they were really challenging the conventional wisdom in our industry of coating technology and corrosion control. And so it's been an exciting ride since then.
You know, Joe, for the viewers of this episode who might have limited or no knowledge about the discovery and the history of carbon nanotubes, could you provide an overview on carbon nanotubes and their unique capabilities?
Yeah, that's a great question. And I'm going to take you back to the mid-'80s again. So in circa 1984, 1985 timeframe, the world knew about two pure forms of carbon, and one's going to be diamonds, and the other one's graphene. And everybody knows diamonds. Graphene, if you put a bunch of sheets of graphene together, they create graphite, and you can think of kind of like a pencil. And up until 85-ish, that's all we knew about. And then Rice University was conducting a lot of research into the field, in the nanosciences field, and basically discovered the C60 molecule in 85, which has been termed the Buckminster fullerene molecule, or buckyballs you'll hear in the industry. And that's kind of the genesis and the foundation or the building blocks of carbon nanotubes. Nano is kind of getting applied to everything these days, right? And what it is a prefix that means the billionth the size of something. And so carbon nanotube is a nanometer, which means it's the billionth the size of a meter. Very, very small, 1 × 10⁻⁹ power, actually. And, what they lack in size, and they make up for in characteristics and attributes. And so to kind of give an idea of what do they provide that we look for in the coatings that we're using with our technology, I guess the first one would be the self-assembly process. And in the picture that you're showing, that is what we call the self-assembly of the carbon nanotubes. Carbon nanotubes, if you put 1,000, 10,000 of them in resin, they look like powder, look like specks. There's just not a lot to them because they're so small. But they have a phenomenal ability in that they'll self-assemble. And so Rice University has actually termed this Tesla phoresis, which is the ability of the carbon nanotubes to self-assemble. And this quantum network that develops is because the carbon nanotubes come together and form it. That in and of itself is phenomenal. But two other aspects that we are utilizing in our technology is that this quantum network is very conductive. Matter of fact, it's 1,000 times the current capacity of copper. And so it is the most conductive material that we're aware of. And so that does a lot for us in our electron transfer. And then the other thing is going to be the chemical bond or the tensile adhesion. So carbon nanotubes are, the chemical bond is actually greater than what's found in diamonds. And it's, to put it in kind of aspect of our industry, it's about 200 times the tensile strength of steel. So it actually is the strongest and the stiffest material that we know on the planet right now.
So, related to the Tesla carbon nano coating, what advantages does this engineered coating system provide?
That's a good question. There's a lot. I mean, we're discovering new things all the time, but I would say probably the main advantages would probably come back to that self-assembly and the conductive nature. And so what that does for us is a traditional zinc-rich coating is going to rely on metal to metal, the zinc as well as the zinc to the steel contact in order to transfer an electron. And as the zinc oxidizes, which is what it's designed to do, it actually insulates itself. And so that process is interrupted and you have no conductivity. What's different with our quantum network is that I can take an electron that can be donated by zinc anywhere on the matrix. I could be 3 feet away if I needed, and I could pull an electron down that complete quantum network and deposit it at the damaged area. So we really take advantage of those properties and get a real, true, sustainable cathodic protection. And the picture that you're showing now shows an OCP, which is an open circuit potential, which you basically test the potential between 2 points of a cell. And as you see, as the electrolyte penetrates this film, about halfway through, it looks like someone turns a rectifier on. And that is because we've reached that potential for corrosion at the steel surface, and our zinc kicks in and it recognizes it and turns on, and you can see it carries that cathodic protection all the way to the end of this particular test. The other advantage is going to be based on that tensile strength. And so you pick up 3 properties there: incredible abrasion resistance. So the carbon nanotubes lend themselves to a very abrasion resistant film. Adhesion. Because of those chemical bonds, traditional zinc-rich primers usually will pull off in a test. I'll say maybe an epoxy one at 600 PSI. Traditional inorganic zincs are 300 PSI, which is about 4 or 5 MPa. Right now, we're nearing 10,000 PSI on our adhesion value, which is about 69 MPa, and we're getting glue failures. We have not been able to determine what our adhesion threshold is to pull this coating off of steel, because we haven't found something strong enough to glue the dolly to figure that out. The other benefit would be edge retention. And so that's big in the industry right now. Traditional coatings try to address it with a stripe coat. What we're finding is relatively new finding for us is that the edge retention ratio of our carbon nano zinc primer exceeds 100% in many cases. And so you don't have to have secondary surface preparation, and you don't have to have a stripe coat anymore, which is huge time saving and benefit to asset owners.
Tesla NanoCoatings, has well invested in research and development, and also the performance testing that you've done with the Tesla systems of primers, top coats, and other products. Could you cover a few benefits over traditional systems that Tesla NanoCoatings provide?
Yeah, thank you for that question. We talked a little bit about the benefits earlier, and is I think more about how can you kind of really understand, and I can convey to the viewers smart coating technology. As far as our system doesn't deploy its cathodic protection until it's called for, and so it's much more sustainable. And the economic life cycle is going to be reduced of the asset. It's going to be extended so that those costs come down. The fact that we're able to eliminate the secondary surface prep and the stripe coating allows us to basically turn the project around faster. So there's a benefit on the turnaround and the time, but we also eliminate that stripe coat, which is a big cost. And because we're controlling those kinetics of corrosion, and we're not having those Faradaic losses that you would have with a traditional zinc, we don't have to have another coat put on, like a intermediate epoxy, to control those reactions. We're doing it within our own matrix. And so we've eliminated an intermediate coat as well. I would say going outside of the technology a little bit, you can have the best technology in the world, but if you can't get it out of the can and on the surface and that it's user friendly, no one's going to use it. So one of the other tenets of our technology is to make sure it's very user friendly. And I would say some additional benefits in answering your question would be the ability of an applicator to brush, roll, and spray an entire project. So it's not just small areas like a traditional zinc-rich coating would be. You can roll an entire project of ours. You can brush it, you can spray it, you can do all three. So it really gives that versatility. We have very long pot lives. So it really is designed to help the applicator. And kind of as a side and another first for us. So we've taken our 2-coat system that replaced the 3-coat traditional, and we're getting ready to introduce a brand new deck coat, which a lot of the deck coating systems right now are 4 to 5 coats. We've reduced it to a 1 coat. And so you're getting a cathodic protection zinc-rich coating that goes down about 40 mils or greater and has the non-skid in it, and it's ready for return to service the next day. And so we're real excited to be launching that very, very soon.
That's very impressive. So which industries are typically using nanocoating systems?
Yes, we started out in early 2000 is when the company's been founded. So we've been around for a little while. And the focus at that time was, where is the most aggressive environment that can really benefit from the value proposition that we have? And we definitely took a look at offshore oil and gas, and then the supporting industries for that industry. And so I would say that was the whole reason that this technology developed, along with some aerospace concerns that we were helping to work on at that point as well on the corrosion side of things. So I would say oil and gas, and we've been deployed on platforms from, we'll say, the North Sea all the way to the Persian Gulf and all points in between. And so that's been our main industry that we've served, and that has really rallied around this technology. But then because of the support companies to those, the OEMs and things, we're starting to see that we're getting some adjacencies in markets because of that and starting to spread that way. We've also got into ones that we were surprised with: trucking, heavy equipment, and then some of the more traditional and marine also is an adjacency for us, and some alternative energies like wind energy, for instance. So we're really starting to see a lot of interest picking up in those industries as well.
Yeah, Joe, I think you and I could have hours worth of conversation and discussion on this technology. In closing out this episode, is there anything that we didn't cover that you would want to leave with the viewers of the episode?
Thank you for that, and thank you for the time. This has been great, and hopefully we get a chance to do this again. I love what you guys are doing, and bringing this to the industry and giving a platform and a forum for companies to show a lot of the innovation. And Tesla's excited to be the recognized leader in the CNT technology, and to commit to our continuing legacy of basically providing owners with the proven corrosion control solutions that deliver that value proposition of the lowest installed cost and the fastest return to service. And while carbon nanotechnology has proven itself a sustainable corrosion solution, we recognize that we are still discovering aspects of what this nanoscience and carbon nanotube technology can do. And we're very excited about, discovering and delivering these new benefits to the industry in the years to come.
Very good. For the viewers, I'll have links and other additional information regarding the conversation that I've had with Joe today. Please definitely check that out. Also visit their website to get a lot of additional information and stay updated on the latest news, and also release information on products as they do become available to the industry. Joe, thank you so much for this opportunity to talk with you today.
Oh, thank you for the opportunity and the forum you're providing. So thank you very much.
No problem. Hey, have a great day.
You do the same.